All right, so start off with a little bit of administrative stuff. Monday, I had a deadline. Monday was yesterday. Okay, it's already been a long week for me. Monday, I had a deadline that I had to submit midterm grades. And so I have to go into the system and I have to mark all students who don't have higher than a 70. I have to mark them, and then the system automatically sends an email out to those students that says, you're at risk of not passing the class, blah, 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 contact your instructor, blah, blah, blah. I just want everyone to know that that's an automated system. That's not something that I am requesting that you come contact me, although my door is open if you want to speak about your grade. But I just want you to know that that's how that process works. For this class and for all your other classes, if you're not passing at this point, you're supposed to get an alert. So if you check your email, you see something, that's what that is. All right? Any questions on that? We have an exam scheduled for Tuesday, next week, a week from today. I think after that exam, if you're still not passing the class, you should definitely talk with me. Because that'll be what, the third exam? That's only the second? Wow, well, it'll be our second exam. And so we only have 2 more, I believe, after that. So, you know, you're kind of at that midway point, and you want to make sure that, you know, getting through the course is still possible. So let's wait till after that exam next week to really kind of determine where you are. All right, so today we're going to cover polynomial functions. We started that last class. This will be the last topic. Our goal here today is to sketch polynomials. That's what our goal is, all right? We've sketched lines, we've sketched parabolas. Now our goal is to sketch polynomials. Now in a normal like 1414 class, your traditional, you know, college algebra course, we would spend like 2 weeks on this. Here we're going to spend, you know, a day and a half. So part of last class today, that's it. We're not going to go any deeper. It can get pretty messy. So let's talk about last class. This table I put over here, I don't believe I gave you a table last time, right? I did draw a table? Oh, okay. I wasn't sure if I got to actually drawing the table. I'm going to put this up here because I'm going to refer to it. This table is what we use to determine the left and right-hand behavior of polynomial functions. And does anyone remember what all polynomial functions look like when you graph them? Like a wave, like roller coaster, right? Except if the degree is less than 2. If the degree is less than 2, it could be a straight line. So we know that these look like wavy things. It's just a matter of determining what the insides of them look like. We know what the outsides of them look like using the leading coefficient test. So let's see if you remember anything from last class. We'll just get warmed up here. So as an example here, I would want us to find the left and right end behavior of this function. F of x equals negative 3x cubed plus 4x squared minus 7. So this is a polynomial function because it has x, right? It has x in different places, but it has our variable. That variable is raised to an integer power. 3 is the highest power we have. 2 we also have, but the highest is 3, right? So that is what determines that it's a polynomial. Now, what is the leading coefficient test? Like, how do I apply that test over there to this? What do I identify here? The leading coefficient I have to identify. What is the leading coefficient here? Negative 3, right? It's the number out in front of the highest power of x. So the leading coefficient here is negative 3. What is the other thing I need to look at? The degree. The degree is the highest power of x that I see. And the highest power of x that I see is 3, right? Then what I will do is I will go over to this table, and the way this table works is the degree can be even or odd. The leading coefficient can be positive or negative. So let's start with the degree. Do we have an even degree or an odd degree? So our degree is an odd number, right? This is an odd number. Odd numbers, 1, 3, 5, 7, 9, 11, 13, right? Those are odd numbers. So we have an odd degree, which means that we can throw this part of the table out. We're not over here, okay? We're somewhere, we're either here or here. Then we look at the leading coefficient, and what we need to look at is whether or not it's positive or negative. So we have a negative, right, leading coefficient. And that means that we are looking at this bottom right-hand corner. We have an odd degree, negative leading coefficient. So the left-hand behavior is that this polynomial will go up. The right-hand behavior is that it will go down. And in the middle, I would be left to try and figure out what happens. Right? That's what we did last class towards the end. So we're going to pick up from here now, and we're going to add some more stuff to this. And then about midway through the day, we'll actually start trying to graph some stuff. Okay, I'm going to give you a different polynomial function. I want us to try and sketch this. I told you that we're going to, about midway through class, sketch these, right? I'm kind of lying a little bit. We're going to start now, but I'm going to do this because I want to lead you into a general way of doing it. And I'm going to kind of do it by pieces. So I'm going to give you a polynomial function, but the way I give it to you is going to be very special, all right? There you go. Now, that probably does not look like a polynomial function to you because of those parentheses, right? But that's the way it's presented, okay? I just want to convince you first that this is a polynomial function. Convince you first. If I were to take this right here and actually square it, that would mean that, right? And then I would have this at the end. So this is equal to that. And then I could multiply these two together using that like FOIL thing where you go here, 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 here. We did talk about that, I know. So let's go ahead and do that and see what we get. X squared would be our first term. That's this times this. Plus an x, plus another x, plus 1. That's what those would turn out to be, right? If I put this together. That's in parentheses, and then I still have x minus 4. Let's go ahead and collect like terms together here. So what would this be? 2x in the middle? Remember, all I'm trying to do right now is to convince you that this is a polynomial function. Just going to convince you first. Now, how do you multiply this together? Do you remember how I told you to do this? No? Like if it's 2 and 2, I think most of you have that down. You do that little FOIL thing, right? But how do you do it when it's 3 terms times 2 terms? Did we talk about this? You remember? It's not, well, it's the same pattern, but you can't use FOIL. What we do is we start with the first one and multiply it through to both of those. So let's do that first. What's x squared times x? X cubed. What's x squared times negative 4? Negative 4x squared. Understand? That's the first multiplication of x squared through. Then you move on to the next term, which is 2x, and you pass that one through both of those. So what's 2x times x? 2x squared, and it's positive, right? So I put plus 2x squared. And then 2x times negative 4 minus 8x. Am I done? Nope. I've got to go to the next piece, which is the 1, and pass that one through to both of those. So what's 1 times x? Just x. And what's 1 times negative 4? Minus 4. Now you are done. You start with each one of these and you pass it through everything over here. This one through everything, this one through everything, and then you're complete. Collect any like terms together now. So how about x cubes? Do we have any other x cubes? Nope. So I just have one x cubed there. Right? X squareds. Negative 2x squared. X's. Negative 7. And a number by itself, minus 4. There we go. That's it. You follow? Okay, so I started the problem out. I said to sketch this, didn't I? And I wanted to convince you it's a polynomial. Do you agree that this is a polynomial? So what do you think it takes to go from here back to this? What do we call that, going from this to this? It's your second favorite F word. Factoring. Yes. Right? That's what it would have taken, right, to go from here back to here? All right? So what I did is I gave that to you already factored. Didn't I? It was already factored. And this is the way I'm going to give it to you on your test. There are going to be a few problems where I ask you to sketch a polynomial. It's already going to be factored for you. And then I'll show you what you're going to do with it. But you need to know that, the difference between these two versions, right? This is not factored, this is factored. I will also give you a few that look like this, and you will have to factor it. But that's going to come later today, all right? All right, so I've convinced you that it's a polynomial, yes? Yes? Now, the reason why this is important to look at it this way is because in order to sketch this, I need to know what the left and right-hand behavior of this is. And to know the left and right-hand behavior, I need to know the degree, and I need to know the leading coefficient, don't I? And when you look at this version, it's not as obvious what the degree is, and it's not as obvious what the leading coefficient is. Maybe not. So what is the degree?
3.
The degree is 3. What is the leading coefficient? 1. We agree with this? So what is the left and right-hand behavior of this function? If the degree is 3, I'm going to put D as 3 here for degree. Degree is 3. Leading coefficient is 1. With degree, we're concerned about even or odd, right? With leading coefficient, positive or negative. So we've got an odd degree, positive leading coefficient. Odd degree, positive leading coefficient, it's this one, right? So it's going to look like down on the left, up on the right, and the question mark, right? That's what we still need to figure out. Are there any questions up to this point? You sure? Okay. You sure? All right. I'm going to erase this. I'm going to keep the original problem up here. And we're going to start over. Okay? That was all just to convince you that's a polynomial function, that we could find the leading coefficient and the degree. We just did it. But that took some time, didn't it? Maybe there's a faster way. All that, multiplying this all out, right, was just so I could find that degree and leading coefficient. Maybe there's a way I can find it without multiplying it out. And there is. But you have to pay attention to what's going on here. So let's see if we can convince ourselves. I don't have any other colored markers. Oh, no, that's a black one. There's some. Well, it's a blue cap, but there's some stuff here. See if any of these work. All right, so you have to think about this, all right? Everyone ready to think today? Not really? Okay, if I were to take just this if I were to take just that and multiply it out, what would be the highest power of x you would get? X squared, right? You know that because you have an x in here, right? And eventually you're going to square it. Do you agree? So look, even more, let's imagine that this is a 1x, all right? A 1x, and I'm going to square it. If I take 1x and I square it, what would I get? Just x squared. You follow me? I take that piece, I look at squared, that's 1x squared, I square the 1, I square the x, I just get this. Now what about the other piece? This piece over here. Look at the x here, this is a 1x, right? What's the power here? There's a 1 power there, isn't there? So if I take that one, that's like 1x to the first power. What's 1x to the first power? That's just x. Understand? What's x squared times x? X cubed. 1x cubed, isn't it? 1x cubed? Wasn't this the degree? Wasn't that the leading coefficient? Yeah? That's the way we'll do it. It's faster. I'm going to give you a couple more examples, and we're going to come back and actually sketch this. I want to make sure you got this. Can you give me, for this function, can you give me the, let's put a 2 right there, 2x minus 3. Can you give me the degree? Okay, so how are you getting the degree? You got an x here, right? This is actually like a 2x to the first power. Got it? This is really like an x to the first power. And this one is like an x to the first power. And if you put all those together, you would get what? 2x cubed. What's the degree? Leading coefficient? 2. Understand? Let me give you another one. What do you think? 8x to the power of 4, is that what you said? Yep. All right, so let's see. This right here is like a 4x to the first power, 2x to the first power, and this one is just x squared, right? It's just by itself, x squared. So 4 times 2 is 8. And then x times x squared would be x to the 4th. So if we multiplied this all out, sorry, this one, if we multiplied it all out, which would take us time, the first term we would have, the highest power of x we would have, would be this. Guaranteed. But see, we didn't have to actually do it, which is nice. So that would have a degree of 4, which would put us in the even column, right? It would have a leading coefficient of 8, which is positive. So we'd be right here. Understand that? We'd be using this. Is that good enough to clarify it, or you want another example? We're good? Sure? Yeah, sure. You all right? Okay. I work for you. You tell me. You want more? See more? I'll show you more. All right. I just erased what I wanted to do. All right. It was f of x is, was it plus 1? Yeah. Plus 1 squared x minus 4. Okay, we are going to sketch this. You ready? The first step to sketching this is to determine the left and right behavior. We've already done this, all right? That's the first step. Let's call this step 1, everyone. Step 1, left and right behavior. So you would look at this, and you would say, all right, this is really like an x, what? Sorry, 1x squared, right? And this one is really like Well, 1x to the first. And if I put those together, 1x squared times 1x to the first power. I don't really need those ones, do I? Not really, but what would this be? X cubed, right? What is the degree? 3. We've already done this, I realize that, okay? The degree is 3. What's the leading coefficient? 1. And off the table, what would it do? The left side would do what?
Go down.
Go down. The right side would go up. In the middle, question mark. Who knows? We're about to know, but y'all clear with that? Okay. So do you remember when we were graphing parabolas? Parabolas, those U's that opened up and down? That the steps we went through, we would say like, okay, does it open up or down? We would find the vertex, right? That highest point or the lowest point, and then we would go find the x-intercepts. What we're going to do for polynomials is we're going to determine the left and right-hand behavior, just like we did, and then the next step is to get the x-intercepts. We're going to find x-intercepts. That's the next step. X-int, is that all right? X-int is our next step. And the way that we find x-intercepts, just like we did with the parabolas, is we set y equal to 0. Now, y for us is really this. That's y. So that means we're just going to set all of this equal to 0. So I'm going to take the entire function and set it equal to 0. Okay? Now, the good news about this is that this is already factored. Do y'all see that? That's already factored. If this had not come to us, if I had not provided this to you factored, at this step, you would have had to factor it, which is what we're going to do in a little while. So I'm starting off, the first problems I'm giving you, they're already factored. That step's not there. It makes it a little easier. Later on, we'll factor. Okay, so when it's factored, you have multiplication here. All you have to do is set each factor equal to 0. So you take this factor right here, x plus 1. That's called a factor because it's separated by multiplication. Take that factor, set it equal to 0. Take that factor, set it equal to 0. And you'll get solutions here. Understand? Those are little miniature linear equations. You just solve for x on each of those. So subtract 1 from both sides. One solution here is -1. I'm going to box it. And then the other solution here is 4. You all good? It's going to come into play. All right? It's going to come into play, but I'll show you where it's going to come into play in a minute. I just want to make sure everyone's up to speed here. I gave you a function. It was already factored. You had to mess around with this to get the leading coefficient test to work for you. The trade-off was that you didn't have to factor it. It was already factored, so the x-intercepts were pretty easy. Is that okay for me to say that? That was pretty straightforward over there? Okay. Let's take a look. I'm not going to give you step 3 yet. I want to just take a look at where we are in terms of this picture. If I were to start drawing this, here's what I would have. I know for sure I have x-intercepts at these 2 points. So if you want to look at these as points, it's -1, 0, and this one is 4, 0, right? Because it's an x-intercept, your x value is 4, the y value is 0. -1, 0. So let me go ahead and plot those points over here for us. -1, 0, that would be here. 4, 0 would be there. Agreed? Those are the only places that this graph should ever touch or cross the x-axis, right? I should never touch anywhere else on this x-axis. Because if I do, then I'd have another x-intercept. And these are the only 2 that exist. Agreed? The other information I have is what? What else do I know about this graph? The left and right-hand behavior. What does the left side do? Goes, I don't remember. Does it go down? It went down forever. and the right side should go up forever. And this has to look like a roller coaster. It has to be smooth and curvy. Remember that? So the only way I could draw a smooth, curvy roller coaster that would go down on the left and up on the right, just watch me do this. Do not write this down on your paper yet. I would have to go from this point down, right? And from this point, I'd have to go up. Right? Do you see that? That so far matches what I'm supposed to have. The question is what's happening between these two, right? So what does it look like happens to you? Does anyone want to volunteer and come up here and draw the middle for me? If I don't have any volunteers, you don't have to. You can just tell me what you want me to do. Or you want to draw it? You're going to be on camera. That's okay? All right. I'll give you the red one because it's going to be wrong. No, I'm just kidding with you. Just go for it. Just go for it. Okay? Good. All right. Anybody else? Have a different version?
I think the same but smaller.
Oh, the same but not as high maybe?
Yeah.
Okay.
Or more curvy.
Yeah.
Or more curvy? Yeah, this is, well, yeah, you could, this looks like a roller coaster. This has curve to it. It's smooth. I'm okay with that. You could come in here and do it a little lower like this.
Yeah.
You could do that. It wouldn't be more correct, all right? These would both be acceptable. Unfortunately, it's not correct, though. All right? But I have to explain why. I mean, that's a very natural, it looks reasonable like that it would be that, right? Let me try and draw a different version for you, okay? So here's my version. I come in here. How about this?
I know what you can do. Yeah.
What about that? That's kind of the reverse of what you did, right? You could look at it this way. With the red one, if this roller coaster, it went up, it punched through the x-axis, didn't it? Punched through it, then it came up, came down, and then it kind of like, I don't know, how would you describe that? It kind of curved. What did it do with the x-axis? It kind of like touched it and just went off, or you could say almost like bounced off and went up. Understand that? See here, you cross through, and here you bounce off. As opposed to the blue one, which did what? Bounced off and then crossed through. Understand the difference between those two? Because I'm going to be using those two words, crossing and bouncing. I'm going to use those as technical words in here. So, do we all agree that it could have been one or the other, that they're both good guesses? Yeah. It's the blue one, though. And here's why. You were asking what about the squared, right? Okay, when you go back up to these factors and you look at these powers, the power here is 2, right? The power on this one is what? 1. We call the power up there the multiplicity. That's the name of it. The multiplicity of this x-intercept. So this right here is its multiplicity. And what I'm here to tell you is that if the multiplicity is even, you will bounce. If the multiplicity is odd, you will cross. Okay, so look at this number right here. This number right here is what type of number? Even or odd? Even. That's an even number. 1 right here is odd. Please keep in mind, this has nothing to do with this, all right? These are completely different ideas. Multiplicity is either even or odd. If the multiplicity is even, then the corresponding x-intercept, you bounce. I will bounce here. If the multiplicity is odd, the corresponding x-intercept, you will cross. One of the biggest mistakes that students make is that they look at this number to determine the multiplicity. Like, look at that number right there, 4. You would say that's even, right? And so you might think, oh, it's going to bounce there because he said that even bounces, right? That's not what you're looking at for the crossing and the bouncing. What you're looking at is the power on the factor. The power on the factor determines what happens there. Do you see the difference? Okay, I'm going to have to do a couple of these examples. So the answer, I'm going to start over, like erase this, and I'm going to erase the blue one. And I'm going to come back. I'm going to do step 3, which would be the determine multiplicities of the x-intercepts. That's the next step. So what I did here is I look at the x-intercept -1, 0, right? This came from an even factor, right? That came from an even factor, and that means I will bounce. That's the first x-intercept. The other x-intercept, 4, 0, came from an odd factor, which is this one, and that means you will cross. The fourth and final step is the sketch. So the way that you will do the sketch is in this order. X-intercepts get put on the graph first. So you put these 2 dots here first. What comes after the x-intercepts? Nope. The end behavior, right? Left and right behavior. You must do it in this order, okay, or else it'll get messed up. The end behavior, and then after you're done with your end behavior, you have this picture, right? From this picture, you draw the middle using your information about your bouncing and crossing. So when I start to draw this like this, I know that when I get to -1, 0, I need to bounce, right? So I need to bounce off that, and then come down, and I need to get back to this point. And when I get to that point, what am I going to do? Cross through, and it's obvious from the picture that's the only thing that could happen, right? So I cross through. Yeah? Now, one very natural question would be, how low do you go here, right? Like, do you go like that, or do you bounce off and come down like this and draw it like that? How low you put that piece does not matter, right? We're all going to have slightly different pictures. And the reason is because we are not ready to try and figure out how low that goes. This is not like a parabola where we can find the lowest point. That is not possible in this class to find the lowest point here. You have to take Calculus 1 in order to find those lowest points. So we will kind of wave our hands at it and say, hey, look, this is the general picture. It's good enough. We live with it. It's good enough for this, for what we're doing. All right? Y'all look thrilled. Let's do another example. So we're going to look at sketching these polynomials kind of as a 4-step process. Okay, what about this one? Let's sketch this. I'm going to have to assign you homework tonight that I'm going to put on the board, because the section in here on polynomial functions is exactly 1 page, and it has 4 little pictures on it, and it's just garbage. Okay? I want you to know a little bit more about polynomials than that, all right? So that's why you won't have homework out of that section. I don't mean it's garbage like it's useless. It's just I'm giving you more, all right? You get more for your money here, all right? All right, so here we go. Function, let's go with x squared, and let's do x plus 3, and let's do x minus 4 squared. All right, that would be a polynomial function if we could multiply it all out. It would be, but I'm not going to multiply that all out. So the first step is for me to find what? The degree and leading coefficient. So let's talk about, this is going to be the end behavior. All right, what am I going to look at? Okay, so this one is like, this one's acting like x squared, isn't it? The next piece is acting like x to the first power. And the last one is acting like x squared. And if I put all those together, what would I get? X to the fifth. You just add all the numbers together, right? 2 plus 1 plus 2, that's 5. And what would the leading coefficient here be? 1. So we are an odd degree with a positive leading coefficient. Down on the left, up on the right again, right? I should have made it a little more interesting, but I'll do that on the next one. This one goes down on the left, up on the right. What happens if you mess this step up? Your graph's going to be wrong because you're going to base all of the way you draw it off of how things come together, and if this is off, it's going to be wrong, right? So make sure that you understand how we're getting this left and right behavior from here. What's the next step? The x-intercepts. So to do the x-intercepts, all I have to do is set the function equal to 0. How many factors do you see there? How many distinct factors are there?
3.
There's this one, and this one, right? You have to set each of these equal to 0. Students often have trouble with this one because it's so simple they like forget about it or something. But you do have to set this equal to 0. So x has to be set equal to 0. What about the next one? X plus 3 has to be set equal to 0. Okay, next one. X minus 4 has to be set equal to 0. Those are your 3 factors. Now set them all equal to 0 and see what we get. How about this one?
0.
It's already set equal to 0. It is 0. That's it. That's your answer. X is 0. Next one, negative 3. Last one, positive 4. Okay. Third step, determine the multiplicities of the x-intercepts. So let's take a look. I have 3 x-intercepts, right? I did not write them down as points, but I'll go ahead and do that. It's 0, 0, negative 3, 0, and 4, 0. Those are my 3 x-intercepts, aren't they? I want to figure out if I'm going to bounce or if I'm going to cross at each of those. So how about at 0, 0? I'm going to cross or bounce? Bounce? Why bounce? What is the power? What's the multiplicity? So you go back and you look at the factor it came from, right? What's the power on that? It's even, right? It's even. And because it's even, you're going to bounce. Now, if you need an arrow or something, like why is that even? It's because of that, right? What about the next x-intercept? Negative 3, 0. What's the power on that one?
1.
It's a 1, right? If it's not there, it's a 1. And because of that, that's odd, right? And that means I'm going to cross. And then the last one, 4, 0, is even. But not because the number 4 is even, right? It's because the power of the factor is even. And that means I will bounce. So when I draw this, I'm bouncing twice and crossing once. Picture time. All right, what do we start with? Your x-intercepts, right? So let's just put them down, make sure you put them in the right place. 0, 0 is right in the middle. -3, 0 is here. And 4, 0 is here. And look, these don't have to be perfect. I mean, just make sure they're in the right order. You know, you can't put 4 here and -3 here. What's the next thing I should put on this graph? What? The end behavior. Now, last time I did this, I just drew from here straight down, didn't I? I went like this. On this side, I went up. I'm going to do it a little different this time because if I bounce, I want to allow myself to be able to curve there. So what am I going to do? I know that this side's going down, right? What am I going to do when I get to -3?
Cross.
I'm actually going to cross through, right? When I get there? So I'm going to punch through the x-axis. So I actually didn't need to curve it. I'm just going to punch through. There I am, all right? And then I need to just connect the dots, like in kindergarten. I need to get to this point, 0, 0. And when I get to that point, what am I going to do? Bounce. So I'm going to just draw this, and I'm going to bounce off and come back up, right? And then I have to connect to the next dot, 4, 0. And when I get there, I'm going to do what? Bounce. Now remember, the right side was supposed to come up, right? So notice that when I bounce off this, it is going to do that, isn't it? See how that works? So yeah, somebody else could have a picture that looks like this. So let's say that's one student's answer, and the other student has this. That would also be correct. Right? There's going to be variations in our answers. But the things I'm looking for are your x-intercepts correct? Is your left and right hand behavior correct? And are you bouncing and crossing at the right way? If you have that, then it doesn't matter how high and low you go. Also keep in mind, you can't just you can't do things like this. You can't go up here, come back down, go back up, come back down and then turn around, come back. I mean, I've seen all sorts of crazy stuff before, but you can't create x-intercepts that aren't there. See that x-intercept that I created? It crosses there, and it's not supposed to, right? These are the only places it's supposed to cross. So don't be creating x-intercepts that don't exist. And don't ever take a curve and turn it back on itself like that. That's not allowed either. That's a weird looking roller coaster. Towards the end though. I want to get through all this. I don't want to step away from this right now. How are y'all doing with this? You think you're okay with that idea? Okay, I'll do one more, and then we'll talk about the last type of problem. All right, so f of x is, let's do x cubed times 2x minus 4 squared times x plus 7. First step, end behavior, right? Do you want me to just let y'all try this on your own? See if you can get it? All right, see if you can. What I'll do is, while you're doing that, I'll work it up here, so you can kind of look up if you want and see what I'm doing. Oh, I'm sorry. Sorry. It was squared. I apologize. Sorry. I wrote it down wrong. For those of you still working, you might be graphing it right now, that's fine, but anyone have any questions on the end behavior? Everyone's okay on the end behavior? No issues? X-intercepts? Question on the end behavior? No? X-intercepts, set each of the factors equal to 0. Multiplicities, bounce cross stuff. We're okay? Okay? I'm going to draw it then. I'm trying to squeeze it all in here. Right here. There we go. So my x-intercepts are at 0, 2, and -7. It's supposed to go up on the left and up on the right. So I'm going to draw this. When I go up, I'm going to go up on the left. What happens when I get to -7? I cross. So it's actually going to go up on the left. It's going to cross through there. And then I'm going to try and get back to 0. When I get to 0, it's going to cross again. Cross through. And then when I get to 2, I need to bounce. And then up, like that. And you can see both ends go up, right? Crosses everywhere it needs to cross, bounces everywhere it needs to bounce, and we're done. And that's all I want. Like, I don't want anything more fancy than that. That's good enough. Good? Questions, concerns, comments, complaints? All right. Now the last type of problem that we need to be able to handle would be something like this. Let's go with this. X to the 4th plus 2x to the 3rd. Whoa, 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 I messed up. I apologize. Here we go. Plus 3x to the 3rd minus 4x squared minus 12x. I want us to sketch this. I would expect on your test to see like 1 or 2 of the ones we just did. Maybe 2 of them. You think 2? Those go pretty quick, right? They're not too bad. They're already factored for you, so yeah. Maybe 1 of these. Because this problem is going to take a little bit of time. What do you think of what you're looking at there? Does it look intimidating? A little bit? No? What type of function is this? Is it a line, a parabola, or a polynomial? It's a polynomial. Now this one is not factored, is it? This one is not factored. But that's actually a good thing for the first step. The first step is the end behavior, right? Would you agree that I know the degree and leading coefficient right now? Yes. I don't have to do any work. I just look at it. Degree is the highest power of x. Degree is 4. Leading coefficient is 1, which is positive. The degree was even, right? So it's going to go up on the left and up on the right. Don't know about the middle. Even degree, positive leading coefficient, right there, that one. Second step, x-intercept. This is the part that's going to be harder because it's not factored, is it? It is not factored. But it's the same procedure. I set the function equal to 0, right? Do y'all understand what I mean by it's not factored? You don't have like the parentheses, the little things? Okay. So guess what you get to do? You get to factor it. So do you remember the steps for factoring? This factoring is on this test, right? Factoring is the first thing we did after the last test. So this will be kind of like the grand finale of the test will be this problem because you have to factor in it. So what did I? Oh, you're going to split it because there's 4 terms? Yes, I agree. But one thing first. What's the first step for factoring? GCF. Do you see a GCF? X. Everyone see that there's an X in every term? Yes? There's an X in every one of these? That's it though. There's not a number in all of them, just an X. So I pull the X out. Watch the way I write this. X cubed plus 3x squared minus 4x minus 12 equals 0. I have pulled the GCF. Now, the thing that's left in the parentheses is 1, 2, 3, 4 terms group. So I'm going to split what's in the parentheses right there, and I'm going to try and pull a GCF out of the first two only. What do these both have in common?
X squared.
X squared. Now watch the way I write this, okay? We have to be careful with our parentheses. We already have this here, don't we? Like that's already there. I'm trying to break down that inside. So the inside, I'm pulling an x squared out of these two. And what am I left with when I pull the x squared out of those two? X plus 3. Now you go to the other two, and you pull a GCF out of these two. Is there a GCF out of those two?
4.
4 or
Negative.
-4. Which is it going to be for you?
Negative 4.
-4. Pull a -4 out. Why do we want -4? So that this in here can be x plus 3. So if I distribute this back through, I get back these two. Now, I want you to focus all your attention on the stuff in blue right now. The stuff in black on this row is the same as the row above it, right? So now my next line will be this. And then tell me what this blue thing turns into. Okay, we did this. We said if these two match, right, which they do, you write that down, right? You write that down, x plus 3, and then what goes in the other parentheses?
X squared minus 4.
X squared minus 4. It was the two pieces in front. X squared minus 4. Okay. Anybody see anything else? X squared minus 4 is actually a difference of squares. That's one of those special ones. We did that in here also. So this should break down to be what? X plus 2, x minus 2. We're all right? So this piece right here becomes these two. Understand? Okay, let's just backtrack. We had this big ugly polynomial equal to 0. I pulled an x out. Counted 4 terms. So I do grouping. Pull a GCF out of these two here. Pull a -4 or GCF out of these two. These two things match. So we write that down with the two pieces in front in a set of parentheses. Say, oh, that's a difference of squares. That breaks down to be this. And now, this final line here, I do not need these parentheses anymore because I no longer have a bunch of addition in here. It's a bunch of things that are being multiplied. This times this times this. So I can just write like this. That is completely factored now. And I can set each factor equal to 0. You get it? So I set x equal to 0, x plus 3 equal to 0, x plus 2 equal to 0, x minus 2 equal to 0, and I find answers for each of those. So 0, -3, -2, and 2. What would be the next step? Multiplicities. What about these factors? What can you tell me about every single one of these factors? They're all odd multiplicities, right? It's x to the first, x plus 3 to the first, x plus 2 to the first, x minus 2 to the first. They're all odd multiplicities, aren't they? Which means we're going to do what at every single one of these?
Cross.
Cross. I'm just going to put a C